Hello, I am Ipshita Ghosh. Currently, I am working as an assistant professor in EC department at Swami Vivekananda Institute of Science and Technology, and my subject is analog circuit, and whose code is EC402. Okay, so in today's lecture, we are discussing about rectifier. First, we have to know why we need rectifier. Many electronic circuit basically uses DC voltage for their operation, and we can easily convert AC voltage or current into DC voltage or current by using a device which is known as PN junction diode, and this diode allows electric current to flow in forward bias condition and blocks the current in reverse bias condition. So simply a PN junction diode allows the electric current to flow in one direction only, and this unique property of diode basically uses in a rectifier. So now we need to know what is rectifier. A rectifier is an electronic device that converts an alternating current into a direct current by using one or more PN junction diodes, where the diode behaves as a one-way valve that allows the current to flow in a single direction, and this process is basically known as rectification. And these rectifiers can be made in a variety of shapes, including semiconductor diodes, SCR and vacuum tubes, depending on their applications. Now, these are the different types of rectifier. So, it is basically classified into two types. Number one is half wave rectifier and number two full wave rectifier. The type of rectifier that converts only one half cycle of the alternating current into the direct current is known as half wave rectifier. Similarly, a full wave rectifier converts both positive and negative half cycle of the alternating current. And this full wave rectifier are classified into two types. One is center tap full wave rectifier, where only two diodes are used, and another is bridge rectifier, where total 4 number of diodes are used. So this is the basic structure of the half wave rectifier, where we can see an AC supply, one transformer which is step down, and a diode and a resistor. Between both the transformer and the resistor is a diode, and a circuit receives the alternating current from the AC supply, and a sinusoidal waveform is commonly used to depict alternating current. Here one diode is used. A diode is a two-terminal device, okay, and a resistor in an electrical component that limits the amount of current that flows through it. So here is a transformer is used, which is a step down transformer. Normally the transformer is a device that lowers or higher the AC voltage. The AC voltage is reduced from high to low by the step down transformer and low to high by the step up transformer. But this is a step down transformer. And here you can see the AC input and the pulsating DC output. Now what is this pulsating DC output? Some AC component is connected or is mixed with the DC output component. So this is the basic circuit of the half wave rectifier, where an AC input, transformer, diode, resistance and DC output, and here we can see the input waveform and output waveform. So the figure shows the half wave rectifier circuit with a semiconductor diode and a load resistor, and there is no smoothing filter used. So the diode is series in with the transformer secondary as well as the load resistance RL, and the transformer primary is connected to the AC input. So after each and every half cycle, the input wave, its AC voltage from across the secondary winding reverses their polarities, and the diode is forward biased and conducts current during the positive half cycle of the input AC voltage. That means when the top end of the secondary winding, which is A, is positive compared to its lower end, and at this condition we are considering the diode forward resistance is supposed to be 0, but in practical cases there is a small resistance present, and in this case the input voltage is applied straight to the load resistor during the positive half cycle, making its upper end positive compared to its lower end. So the output generated, the output voltage waveform, that is identical to the source voltage. So in this case the output is only the first half cycle. Now when in case of the input, the negative half cycle, the diode is reverse biased and does not conduct during the negative half cycle of the input AC voltage. That means whenever the lower portion of the winding is positive as compared to the upper portion. So as a result, the current across the voltage remains 0 during the negative half cycle. So it is clear from the diagram that output is a pulsating DC rather than a steady DC. So that's why it is termed as a half wave rectifier, because it only uses the half cycle of the input wave. Okay, and thank you.